Okay, so I'll do some more examples related to Jordan form and diagonalization and so on. Okay. More examples. On canonical forms. Okay, so when I say canonical form, if it is diagonalizable, we would like to find its diagonal form. If not, we can find its Jordan form if it exists, and so on. Okay, so how would you proceed? Well, since it is 3 by 3, you can just directly compute the characteristic polynomial, find the roots, and then if the roots exist, then you know that it has a Jordan form. Otherwise, it doesn't have a Jordan form. Then it has a rational form. I didn't talk about that. And if it has a Jordan form, then you look for eigenspaces, and if we have 3 eigenvectors, then it will be diagonalizable. Otherwise, it won't be diagonalizable. Or you can directly look for invariant factors using Schmidt normal form. And once you get the invariant factors, then you can decide directly whether it is diagonalizable or not. We can proceed both ways since it is 3 by 3. It is easy. Let me just try to find the characteristic polynomial and then see if it is diagonalizable. So what is the characteristic polynomial? It is the determinant of x times identity minus a. So it is just the determinant of 3 minus x, 0, 1, 2, 4 minus x, minus 2, 1, 0, h minus 3, right? And then we can write it as follows. It is 3 minus x, and then determinant of this, which is just 4 minus x minus times, sorry, x minus 3. No, not x minus 3 minus x. We answer really. 3. Şurada x eksi 3 olacak. Bu da yanlış olmuş. X eksi 3. Tabii. Şurada eksi 2 olacak. Evet, haklısın. Şeklinde aklım bir şey gitmiş. X eksi 4 olacak. Evet, hepsini yanlış yapmışım. Neyse, tamam. Okey. Bu da x eksi. Zaten bu x eksi 3 değil mi? Buradan 0 gelecek. and then plus 0 times something, plus 1 times. I put this 2, so it's 0 minus x minus 4, so it is just 4 minus x. Okay, right? Doğru yaptım değil mi? X eksi 3 çarpı x'in çarpımı bu çarpı bunun determinantı 0 eksi bu, o da 4 eksi x. Okay. Let's start to get so for x, which is just the determinant of x minus identity minus a, and that is just, you see, x minus 4 is the common term, so that we just take x minus 4 parentheses, x minus 4 times the first term is just x minus 2 squared minus 1. I can just calculate this as bu birin karesi değil mi? Yoksa x eksi 3 eksi 1, x eksi 3 artı 1. Okay, so this is just x minus 4, x minus 4, x minus 2. So x minus 4 squared x minus 2. So I have two eigenvalues. One of them is has multiplicity 2, the other one has multiplicity 1. So lambda 1 is 4 and multiplicity k1 is just 2. Okay, and lambda 2 is 2 and the multiplicity is 1. Okay, now let's see what the eigenspaces are. So W lambda 1, which is W4. How would you find the eigenspace, eigenvectors? Well, you look at, so x minus identity minus 8 times 3. Now, şuna bakıyorum değil mi? 8 times 3 is equal to lambda 1 times 3. So 8 times 3 is equal to 4g, or a minus 4 times identity v equals 0. So A'dan 4 çıkartacağım. So we subtract 4 times identity from A. So if you do that, bunlar 4 çıkartırsam burası eksi 1, 0 eksi 1 olacak. Geri kalan ise aynı olacak. So A minus 4 times identity is minus 1, 0, plus 1, 2, 0, 2, minus 1, 0, minus 1. And here I have the vector V. Let's say it has coordinate ABC, 0, 0, 0. Right? V is just the vector ABC. Well, this is rank 1, right? There is only one linearly independent row, 1, 0, 1. All others are just multiples. So this is just, okay, basically minus A minus B equals 0. And then 2A plus 2B equals 0. And minus A minus B equals 0. So there is only one equation. And we can solve this as what? Let A equals 1, for example. Then what is B? B is just, of course, minus 1. Final? Evet, eksici olacak, haklısın. B nedir? B is arbitrary, right? So this is one solution. I can just let V1 to do 1, 0, minus 1, for example, V2. Another solution, I can just choose A equals 0, B equals 0. No, sorry, C equals 0 and B equals 1. So 0, 1, 0. Tamam mı? İki tane, so we have two linear independent solutions. Therefore, so W1 W4 is spanned by these two eigenvectors 1, 0, -1, 0, 1, 0. So it is dimension 2, right? It is dimension 2, which is equal to K1. Therefore, this matrix will be diagonalizable, right? Because I have two eigenvectors here. For the other one, I will obtain one eigenvector, because if this is an eigenvalue, there is certainly one eigenvector. So for the second one, W2, which is just this one for the eigenvalue. So this time we consider this equal to A times B equals lambda 2 times B, so it is just 2B. Therefore, A minus 2 times identity B equals 0. What is A minus 2 times identity? A is this matrix. I subtract 2 times identity, so this will be 1, 2, 1. The rest will be the same. So here's the first x years. 2, değil mi? 2 çıkarttım çünkü. Eksi 1, 0, 1. Okay. And then D, let's say D in F equal 1 and 0, 0, 0. So we get two equations. So D minus F equals 0. 2D plus 2E plus 2F equals 0. And this is the same thing, right? This is minus 2 plus F equals 0. The first and the third equations are almost the same. I can just cancel this out. From this, we get D equals F. And if I put it here, so if I plug this into this equation, D ile F aynısı, bu ne demek? 4 tane D artı 2E eşittir 0. So let E equals or D equals 1. So this is rank 2, right? It has two linearly independent rows. It has rank 2. Therefore, solution space has dimension 1. 3 minus the rank, which is 1. So I'll get only one eigenvector. So let D equals 1. Then E is minus 2 and F is of course equal to D, which is 1. Therefore, the only eigenvector we get is just 1 minus 2, 1. So the eigenspace for the eigenvalue lambda 1 is spanned by this eigenvectors. And the eigenspace for the second eigenvector, which is 2, I have one eigenvector. would it be possible to obtain two linearly independent eigenvectors here? Yani burada bir tane elde ettim. İki tane elde edebilir miyim? Niye?
Hocam, hocam o zaman şey olmaz ki ama hani böyle
Eğer ilerleyen farklı eigenvektörler getiriyor olsaydık onun generator sadece bu olmazdı.
Yani iki tane burada linearly independent vektör elde edebilir miydim?
hocam diagonalizable olmaz ki ama o zaman zaten.
Okay. So if I had two linearly independent vectors here, then I have another two linearly independent eigenvectors here. Evet. Then putting those four vectors, I would get linearly independent four vectors in a three-dimensional space. That's not possible. Okay. We know that if you have basis for the eigenspaces, when you put those basis vectors, together, you get a basis for the big vector space. So if I had two vectors here, which is the basis for W2, and two vectors here, which is the basis for W4, then if I put those four vectors together, that would be a basis for V. But V has only dimension 3. Therefore, that wouldn't be possible. Okay. Now, so we have three vectors, eigenvectors. Now, this beta. So I take this vector, and this vector, and this is the basis for B, which is R3, consisting of eigenvectors. Therefore, hence, A is diagonalizing. And if you let P the vector, the matrix, just take this basis vectors and put them like this. So this is, if you want, let me just call it. So this is V1, V2, and let's say V3. V1, V2, V3, V1, V2, V3. Then we know what? Then P inverse A, P is the diagonal matrix. And what are the diagonal matrices? This corresponds to the eigenvalue 4. So I have 4 here. This also 4, and then I have 2 here. So that would be the diagonal form. Okay. İsterseniz bunu kontrol edebiliriz. Let's check this out. So, what is?
Hocam kamera dondu.
Pardon. P, A, P, D'ye eşit. Niye P'ye eşit bu? Bakın şöyle. A, P yerine B1, B2, B3 yazın. So, when you multiply this columns by A, you get A times V1, A times V2, A times V3. But these are just not yeah, A, okay. These are just eigenvalues, right? So eigenvectors. So this is just 4 times V1. This is 2 times V, no, 4 times V2 and 2 times V3. And then you apply P inverse to this. But we know that P times P inverse is identical. So P times P inverse times. This is identical. V1, V2, V3. So when you multiply this, you get P inverse times V1, P inverse times V2, P inverse times V3. We are doing E1, E2, E3. So what is this then? This is just 4 times P inverse times V1, 4 times P inverse times V2, and 2 times P inverse V2. But this is just E1, so this is 4 E1. This is also E1. Sorry, this is E2, 4 times E2, and P times V3 is just E3. So it is just 2 times E3. 2 times E3. So what is this? Yeah? And inverse A2 is just 4 times E1. 4 times E1 is this. 4 times E2, 2 times E2. Tamam mı? Yani bunu tabii direkt baz değiştirmeden de biliyoruz ama baz değiştirme işleminden.
Ben şey yaptım. 2, 4, 4 yaptım. P ve P'yi ona göre.
Olmaz, olmaz.
P,
Yani şey tabii,
P'yi karar.
yani how you you know order your eigenvectors depending on how you order your eigenvectors, this diagonal entries will show. Yani P matrisini şöyle seçseydiniz. V3, V1, V2 o zaman P inverse A, P olacaktı. V3 hangi eigenvektördü? 2'ye denk oluyordu. Değil mi? Bu 4'e, bu 4'e. O zaman bu matris elde. Tamam mı? Bir sınav sorusu bu. Peki. Başka? Bir de şuna bakalım. Tahtayı değiştireyim.
Bu soruda oyunu bulduktan sonra bunların faktörlerini devirleyip
yani bir kere eğer diagonalizable'sa linear yani D3 distinct linear faktörlerin çarpımı olacak. Ama belki diagonalizable değil. O zaman öyle olamaz. Karakteristik polinomdan şeyi okuyamazsınız. Hani bu diagonalizable mı değil mi? Yani özel durumlarda okuyabilirsiniz de böyle repeated root'lar varsa o zaman sıkıntı. Minimum polinomu biliyorsanız o zaman şöyle diagonalizable mı değil mi anlarsınız ama diagonalizable değilse Jordan formu nasıl olacak onu da bilemezsiniz. Bilemezsiniz. Çünkü şeyi hatırlayın. Nasıl bulduk Jordan formu? Bütün DN'lere bakıyorsunuz. Her birisi bir Jordan form verebilir, bir Jordan blok verebilir. DN onlardan bir tanesi ama belki yukarıda başka Jordan bloklar olabilir yani.
Hocam bir şey
Büyükse o zaman şey yapmak zorundasınız. Hani Smith normal formu yazıp oradan bulmanız lazım. If the matrix is big, not 3 by 3, but let's say 5 by 5 or 6 by 6, then to see whether it is diagonalizable or not, you need to find invariant factors. Okay. I mean, you can do it this way, but if you cannot find enough eigenvectors, then you will say that, okay, this is not diagonalizable, it has a Jordan form. But what is that Jordan form? To see what kind of Jordan form you have to write down the invariant factors.
hocam bir şey sorabilir miyim?
Sor.
Hocam bir şey diagonalizable olmayıp ama Jordan formu olabilir değil mi?
Tabii ki.
Tamam.
Yani genelde de öyle. Hani, genelde öyle değil de. O yanlış bir laf ama hani diagonalizable değilse Jordan formu yani diagonalizable olmak da Jordan formu olarak görülebilir zaten de. Neyse. Bir tane daha örnek yapayım. Bir tanesi zaten 20 dakika alıyor. Pardon. Şöyle. Okay. Find the canonical form of seven minus 1, 2, 5, 1, 2, minus 8, 2, minus 1. Okay. Since I know the answer, this is not diagonalizable. Well, actually, for this one, okay, it's 3 by 3. We can still find the Jordan form without finding the invariant factors. Let's see if we can do this. Let's write down the characteristic polynomial. F of x, which is determinant of x times identity minus 8. Size direkt cevabı söyleyeyim. X eksi 3, x eksi 2'nin karesi. So it's kind of similar to the above one. Okay, two different eigenvalues. One of them is repeated. So lambda 1 is 3 and k1 is just 2. Lambda 2 is just 1. Pardon. This is 2 and multiplicity is 3. Okay. Now let's try to find the eigen. Well, for this one, of course, eigenspace can be at most one-dimensional, and we have also always one eigenvector. Therefore, this will be one-dimensional. So let's just find that one. W lambda 1, which is W3. How can you find this? Well, A minus 3 times identity V equals 0, right? This is the eigenvector equation. So let's solve that. Bir eigenvalue'miz varsa ona karşılık gelen tabii ki bir eigenvektör var. Yoksa o sayı eigenvalue olmaz. Dolayısıyla bir tane, en fazla da bir tane var. Bir tane de olduğuna göre başka da yok. Evet. So A minus 3 times identity. I subtract 3 times identity from this. We get 4 minus 1, 2. 4 minus 1, 2. 5 minus 2, 3 çıkartıyoruz. 2, 3 çıkartıyoruz. 2. Okay, let's apply, Gaussian elimination. You see, this is just 2 times this. If you multiply by 2 and into this one, you get 0, 0, 0 here. Zaten evet, şundan çıkartalım mı? Çıkartalım. Ne olacak? 1 eksi 2 yok. Eksi 3 çıkarttık 0. Sonra
Eksi 1 olmaz mı?
efendim
Eksi çarpı ekledik ya.
eksi 1 ile çarpıp ekledik.
Eksi 3'ün yerine hocam eksi 1.
Üçün yeri eksi üç.
Eksi 1. Özür dilerim. Tamam. 0, 0, 0. And that's, enough because we want, this is a rank 2 matrix, therefore solution space is one-dimensional. And what are the equations? 4a minus b plus 2c is 0, and a minus b is 0. Well, this gives me a plus b, and this gives me then, since a is b, so 3a plus 2c equals 0. Şöyle yapalım. A ile B'yi 1 seçmeyelim. 1 seçersek C 1,5 olacak. Bunları 2 seçelim. So let's choose this 2. Then this is 6, so C equals minus 3. So I can just choose my vector to be 2, 2, eksi 3. So the eigenspace for the first eigenvalue, which is 3, it is generated by 2 minus 3. Bazen row yazıyorum, bazen kalın yazıyorum. Yani. Peki. What about the second eigenvalue? So number 2 is equal to 2, and the multiplicity is also 2. So I look at this time, a minus 2 times identity, b equals 0. I subtract 2 times identity, so we get 5 minus 1, 2. 5 minus 1, 2. Minus 8, 2, and minus 3. Okay, so I can just kill this guy and replace with this one. So we get this. Burada da eksi 8, 2 eksi 3. Well, these are linearly independent because this is just minus 2 times this one, but this is not minus 2 times this one. So this has rank 2. Therefore, solution space is one-dimensional. So I have only one eigen vector. Okay, one eigen vector. So we have only one eigen vector. But for this to be diagonalizable, we needed 2 linearly independent eigenvectors. That's not, that doesn't exist. Therefore, A is not diagonal either. So it is a Jordan form. What should be the blocks? Well, one of them is, so J should be something like this. I have already one eigenvector, so that gives me this thing. Or the eigenvalue 3'tür. And here I have a 2 by 2 Jordan block. Right? So it should be like this. Right? So this is the canonical form. But we need to find the generalized vectors. For this one, for this column, I have already a vector. Let's call it V1. Ne bulmuştuk? 2, 2, 3 müydü? 2, 2, eksi 3. So this is the eigenvector for the eigenvalue 2. Here's what I need. Okay, I need the following. There is an eigenvector. Let's say V2 eigenvector. Bir de generalized eigenvector olacak, değil mi? Ona da so eigenvector şöyle diyeyim. So A times V1 is just 3 times V1. But here I need generalized eigenvectors. Well, actually one generalized eigenvector. Nasıl olsun? Bir B2 olacak. So B2 is the A minus 2 times identity V2 will be 0. So this will be eigenvector and A minus. Gerçi buna tepeden başlıyorduk. Bu 3 olacak. Değil mi? Şöyle. Şuradan da B2 diyeceğim. Bu B3 olacak. Dolayısıyla bunu öldürmek için bunları 2 kere vuracağım. Bir kere vurunca eigenvektörü dönüşecek. Bir daha vurduğumuzda gidecek. Okay. Şimdi ne yapmıştık? So I need to find W3 and W2. Finding W3 is easy. This is eigenvector and I have already find it here. I can just find W3. So let's find W3. A minus 2 times identity is this system. So 5 minus 1, 2, minus 8, 2, minus 3, 0, 0, 0. A, B, C, equals 0, 0, 0. Right? That is just A minus 2 times identity times B equals 0. That will give me the eigenvector. So let's do that. Bakalım. 5A eksi B artı 2C eşittir 0. Bir de eksi 8A artı 2B eksi 3C eşittir 0. C yerine 0 yazarsak başımız derde gider. Hepsi 0 çıkar. 2A artı C eşittir 0. 2A artı C eşittir 0 ise o zaman A'ya 1 verelim. C eşittir eksi 2 olacak. B'yi de buradan çözeriz. B'de neydi? Siz söyleyin. 5A artı 2C. Dolayısıyla 5 eksi 4 o da 1. Değil mi? Oldu mu? So, the eigenvector is just A, B, C. 1, 1 minus 2. İnanmıyorsanız ne yapacaksınız? Yani A, B, 3, 2 tane, C, 3, So, you can just do this and see if we have done correctly. Peki, B2'yi nasıl bulacağız? How can we find B2?
Hocam, is that in the kernel of A minus 2 identity square?
Yeah, we can do it this way, but that way, but you know, we have to find this B2. So since we have already specified what is our eigenvector, it should be chosen so that it should satisfy this equation. That's why I'll just try to solve this equation. Senin dediğin gibi de yapacağım. O zaman daha farklı yapmamız gerekecektir. Since I already chose what my B3 is, I have to be careful. B2 should be chosen so that it should satisfy this system. Therefore, we just write that system and solve it. So, A minus 2 times identity, B2 is B2. Okay, now, what is A minus 2 times identity? That was 5 eksi 1, 2, değil mi? 5 eksi 1, 2, eksi 8, 2, eksi 3, ve 2, ona da ABC diyelim. Ve 3'ü bulduk. 1 eksi 2. Now we have to solve this. Okay? Well, again, I can kill this guy. 0, 0, 0. Minus 8, 2, minus 3. A, B, C. Ne yaptık? Eksi 1 ile çarpıp topladım. 0, eksi 3. Now we have these two equations. 5A minus 3 plus 2C plus 1 and minus 8A plus 2B minus 3C is equal to minus 2. Demin ne görmüştük? 2A artı C sıfırdı. 2A artı C sıfır, yani bunu 2 ile çarpıp bunu ekliyoruz, değil mi? So if you add this multiply by 2 and add to this one, burada şey yapabiliriz ya. Mesela A yerine 0 yazabilirim. Hiç sorun olmaz. Like, I just need one generalized eigenvector. Just one solution. So for simplicity, let A to be 0. Okay? If you do that, your system becomes minus B plus 2C is 1, 2C is 1, and 2B minus 3C equals minus 2. Okay. Bunu da 2 ile çarpıp bunu eklersek, so if I multiply by 2 and add to this guy, you get 0. Geliriz. Olsun. B neymiş? So B is minus 1. So what is B2 then? B2. A is 0. B is minus 1. C is 0. Tamam mı? Yani böyle kestirmeleri atlamayın. O işlemin içinde Hani boğulabilirsiniz. Okay. So my eigenvectors and generalized eigenvectors are as follows. V1 var. Neredeydi bu V1? 2, 2, 3. 2, 2, eksi 3. Ve yok bunu böyle yazmayayım. Şöyle yazayım. Ben de unuttum. 2, 2, eksi 3. V2 0 minus 1 0 V3 1 yok nerede yok 1 eksi 3. So if I let P to be this vector matrix 2 2 minus 3 base change matrix 0 minus 1 0 1 1 2 ya da minus 2, then we know what? We know P inverse A P is equal to J, which is just 3 0 0 0 2 0 0 1 2. Derseniz deneyebiliriz. P inverse'ünü bulmamız lazım. Ondan sonra da çarpacaksınız. Şey yapmak istemiyorum. Okay, so exercise check this. Okay. Eigenvektör olan buydu değil mi? Evet.
Değişken eigenvektör olarak alamıyoruz.
Yok. Bu ikisinin yerini değiştirirseniz sorry. If you interchange these two, okay, then you don't get this, but you get this one. Yani bu sırada değil de bu sırada yaparsanız şu bir yapacağına şey burada. Yani o zaman bu ikisinin yeri değişmeyecek. Yani evet. Efendim?
Yerde çalışıyordur sadece bir oldu.
Tabii. Yani, çok kötü bir şey değil o da ama şey değil. Efendim?
2 1 0 içinden yazmaz.
Burası?
Evet. İkinci vektörü birinci vektörle yer değiştirirsem 2 1 0 içinden yazacağım. Yoksa 0 2 1 için.
Yani şunu diyorsun. Bazı şöyle seçseydim. V2 V1 bakalım yani ne yapacaksın? P, B, A, B2. A, B2 neye eşit? A times V2 is just 2V2 plus V3. So this is 2V2 plus V3. A V1 is just 3V1. A V3 is just 2V3. So in this basis, A will be what? So in this basis, So if I say this is the basis order beta prime, beta prime, beta prime. So it will be, so the first vector is the first vector 2 times the first vector plus 2 times the third vector. So it is 2, 0, 1. Second vector is just sent to 3 times the second vector. And the third vector is just sent to 2 times the third vector. So that would be the Tamam. İyi, ara verelim, aradan sonra devam ederiz.
Tamam.